Hello everyone and welcome. My name is Panagiota Katsikouli and I am your instructor for the Introduction to Databases course. Together we will explore what databases are, how to design them, how to use them. We will explore their characteristics and applications. This week is dedicated in giving a brief introduction to databases in general and in the basic concepts of database systems. In this video, we will answer the basic question: what is a database? In particular, we will cover a number of useful definitions to database systems, which we will be using throughout the course. We will next visit the various types of databases and their applications. A common definition of a database is the one that describes it as a coherent collection of data. This data describes something about the real world. We often call this aspect of the world represented by the data in a database as the database's mini-world. The data should also have some inherent meaning. They need to mean something. With regards to the logical, coherent part, here, that means that the data we store in a database need to be related somehow. Just storing employees' paychecks along with weather data in the same space does not result in a database. It results in just storing data without connection, without an inherent meaning. What we store in a database needs to be connected somehow. Everything together needs to be describing an aspect of the real world. For example, a database of OPIT could contain details of the students, which programs they are enrolled in, their contact details, details of the professors, which courses each student takes, which courses each professor teaches, etc. A database can be of any size and complexity. In theory, a database can be one that we generate and maintain manually in a ledger or a notebook, for example. But it can also be computerized, that is, generated and maintained by a digital medium. In computer science and in this course, of course, we only talk about computerized databases. We can define thus a database system as a computerized database, which has an overall goal to maintain information and to make that information available whenever it is required by the various users. Further, we talk about database management systems, or DBMSs, as we will find very often in literature and in this course. These are general-purpose software systems for enabling the creation and management of databases. We talk about general-purpose databases or systems in contradiction to specialized databases, which often contain data and allow for retrieving data of specific type. This might also have specific formats, rules, and constraints. And we also have customized databases for specific applications, as we will see later in this video. But when we talk about database management systems in general, we refer to the general purpose ones that we will cover in this course. When we talk about managing a database, we imply 4 generic actions. That is, to define a database, to construct it, to manipulate it, and to share it among users and applications. Let's take a moment to discuss this. To define a database means to specify what types of information we plan to store in it, its structures, its dependencies, and the constraints. That is, in the example of OPIT's database that we introduced earlier, we would need to specify its particular piece of information. What type would it be? For example, if we wish to store information about the preferred gender of a student or professor, would that be stored as a single letter or as a word? How are the data to be stored? How are the different pieces of information across the database related, etc.? We will talk extensively about this in the upcoming weeks. To construct the database is the process of actually storing the data on a medium. That is, to populate the database with entries, which, controlled by the DBMS, will be translated into bytes of information stored in some type of storage medium. Then, to manipulate a database refers to querying the database for retrieving the desired information. And this is one of the main reasons we make databases, right? We want somehow to store data for safekeeping, let's say, but we also want to get information from this data. And that can be simple queries, such as, for example, get the contact details of OPIT Professor Jota Katsikouli, or more complicated, for example, queries such as get all the information of the students that have failed the courses of Jota Katsikouli. We will learn how to make queries simple and complicated, how to update the database, etc. in the following weeks. Lastly, to share a database means that more than one users or applications can access it at the same time. Consider a database that contains information about the citizens in a country which are registered in the public health system. This system, the database underlining it, should be possible to be accessed at the same time by every doctor or nurse in the country whenever needed, but also by the many various applications that have been designed for querying the database. For example, one application could be for scheduling appointments at general practitioners. Another application could be for updating patient records. Here I show you a simple visual representation of a DBMS. You see here in the core the physical database, the medium, the hard drive simply, where the data is stored, and then the system that allows us to access and manipulate the data. And then we have applications, the software system here, that talk with the system and which are used by the various users. For example, when we use Google search to get results on images showing brown puppies, for example, we are the end users. We use the Google search application on our web application. Our query is translated into database language so that the DBMS can understand it, look into the storage for all the images that contain puppies that are brown, and return it to the DBMS, which will give it to the application that we're using, which will show it to us in some nice and user-friendly way. Over the years, many types of databases are found available. The most basic type is a centralized database, where all information is stored in one location, one computer, for example. As information and demand grows, distributed and cloud database became more obvious choices, where information or the data is stored in many locations or in the cloud. Then we have commercial databases for commercial applications. Other types of databases are namely object-oriented, open source, relational, and NoSQL. Some of these databases we will visit in this course together. But what kind of applications are databases typically used for? What kind of information can we store for each of these applications? Databases are used in literally all sorts of applications across disciplines and professions. In business, for example, databases are used to store and access information on customers, products, sales, and purchases, but also for accounting information and other details on the employees, such as their salaries, their payrolls, etc. In manufacturing, databases are useful for the management of supply chains, tracking the production of the goods or services, tracking inventories in warehouses and the various stores, orders, etc. Similar in banking and finance, the information on customers, their accounts, their loans, their transactions, credit cards, etc. are stored, updated, and retrieved whenever needed via the use of a database. Airlines were actually among the first to use databases in a geographically distributed manner. That is, the data stored were stored physically in various geographic locations. And this data describes bookings of flights, schedules of flights, etc. Next, in telecommunications, databases can be used for storing records on calls, text, data usage of subscribers, their details, their bills, but also information of communication networks. Web services applications of databases are perhaps more relatable. For example, social media use database for storing users' information, info on their contacts, on their posts, etc. Online shops use databases to store information similar to a physical business, but also information about the views on products, the searches about them, etc. Advertisements can use databases to maintain information on the click history for generating targeted ads to users. Then we can have databases for documents, for example, databases for scientific papers, their topics, authors, the actual text, etc. And finally, for navigation systems, which can use databases for storing the locations of places of interest, paths between locations, etc. One can see that applications are many and varied. To sum up, a database is a coherent collection of data. A DBMS is a computerized set of programs for creating and managing a database. When we manage a database, we imply actions such as the definition, the construction, the manipulation of a database, and the sharing of a database among users and applications. We saw that there are multiple types of databases depending on their purposes, and the databases have several and varied uses and applications.